In this video, we will talk about how to calculate the confidence interval of population mean using t-distribution in Python. When we want to estimate the population mean from a sample, if we have a random sample from a normal distribution, so we assume if the population is approximately normal distribution, and the population standard deviation sigma is not known, and if the sample size is not very large, say sample size is less than 30, so the random variable t equals x bar minus mu divided by s divided by square root of n, where x bar is the sample mean, mu is the assumed population mean which we want to estimate, s is sample standard deviation, and n is the sample size. So this term t has a student t-distribution with n-1 degrees of freedom. So after we transform the term from the previous formula, so we can get the 101 minus % confidence interval for the population mean mu is between this lower limit and upper limit. So where this term is called error term is the t value at half alpha times s divided by square root of n. So t half alpha is the t critical value at which the upper part of the probability on the density curve equals to half alpha. So in Python, we can use a very simple function called interval, which inside the scipy stats module. So we have to import scipy stats module as st. Then we can use st.t, t for the t-distribution, then dot interval can calculate the confidence interval at alpha level and with the t's degrees of freedom, and we set the location and scale. So next we will show example in Python. So first, import module for the numpy and scipy.stats. Then we create an array of income data. Then next you can use st.t.interval alpha at 0.95. So which means we have 95% of the confidence to estimate this range of the population mean. And the df means degrees of freedom equals length of this data minus 1. And the location log, we use data's mean value, which will be the sample mean. And the scale, we use st.sen, then inside is also the data, because scale will calculate the standard deviation of the sample mean, right? So we learn this. We'll get the interval, confidence interval, 95% of the confidence interval for the population mean between about 18,793 and 31,649. So next example, we will show step by step calculate the confidence interval. So first of all, we calculate the sample mean using numpy's mean function of data. Then we set alpha level at 0.05. Here, this is alpha means the critical level. Actually, this one is 1 minus this one, right? And degrees of freedom equals length of this vector minus 1. Then we use sample standard deviation. Here we calculate the sample standard deviation equals numpy's STD function of this list income. Then we have to times a factor. Factor is the square root. Inside the square root is the length of income divided by length of income minus 1. Why we have to add this term? Because in the standard deviation of income and the function will divided by n when calculating the sum of the difference between each value and its mean, then divided by n to get average. But for the sample standard error, we have to divide n minus 1, not n. So we have to times this factor to get sample standard error. So run this line. So next we will calculate the sample means standard error. So have to divide sample standard error by square root of length n. So if we look at the PPT, so we have to, this one is S divided by square root n is the sample means standard deviation. So now we calculate using this line. So next we can use st.t's function ppf, which will calculate the quantile value from the given accumulative probability and the probability density curve. So here we have to fill in 1 minus half alpha. So alpha is 0.05. So 1 minus alpha equals 0.975, and with the degrees of degree. So if we show the t value is about 2.16. So next we can calculate the lower limit equals sample mean minus t value times sample means standard deviation. And similarly, up limit is the sample mean plus t value times sample mean standard deviation. Then we can print out the confidence interval at 95% level. So this is the result actually is the same as we learned with this function, right? So in summary, under the circumstance of small sample, where the sample size is less than 30, so if we only can assume that the population distribution is close to the normal distribution, or not skewed, symmetric, very close to normal distribution, and the sample size is small, so we can use the t-distribution to estimate the population means confidence interval using sample mean and sample standard deviation. And t's distributions degrees of freedom equals sample size minus 1. So in Python there are two ways. First is use this function, only one line enough to get the result, or we can calculate step by step get the same results. Thanks for watching.